If you remember anything from Honors Algebra 3 or your geometry class, I sure hope SOHCAHTOA is in the top of that. But I'm going to go back through it. When we're talking about trig functions, we are always just talking about ratios. So when we talk about sine, we're really just talking about this specific ratio of the opposite to the hypotenuse. And remember that when we're talking about these ratios, it depends on what reference angle we're using. If we're going to use this reference angle, it's going to be different than if we use this reference angle, because here my opposite is going to be this side. But if I was using the other angle, then this is the opposite. Okay, but using this reference angle, we've got opposite, or adjacent is the side right next to it, and then the hypotenuse is always across from the 90-degree angle. So our ratios, and this is just used to remember what ratio is which. Your sine is going to be that opposite over hypotenuse. Cosine, we're talking about theta here. Your cosine of theta is going to be the adjacent over the hypotenuse. And then tangent is the opposite over adjacent. I have a very annoying song that I will share with you about this later. You can get it stuck in your head. I don't know, it's kind of jazzy. You might come up with a dance to it or something. Have fun with it. But this is the basics of what we are talking about so far. So relating this back to the unit circle, we're going to make some connections. Let's get one of those triangles back in here. Okay, so say we're talking about 30 degrees, and we're trying to figure out the sine of 30 degrees. We know that sine is opposite over hypotenuse, but the hypotenuse for all of these is 1. So if I'm looking at this 30-degree angle, my sine is going to be 1/2 over 1, which is just 1/2. So this ends up being, sine of 30 degrees ends up being 1/2. If I'm talking about cosine, I'm talking about the adjacent over the hypotenuse. Again, hypotenuse is 1, so I just have radical 3 over 2 over 1, which is just radical 3 over 2. So this is my cosine of theta, or 30 degrees. It's beautiful. And I know I keep referencing back to degrees because we were talking about special right triangles, but still be thinking through the radians on these as well, that we're talking about cosine of pi over 6, sine of pi over 6. That's important. When we're talking about the 45, 45, 90, notice on these that my sine is going to be radical 2 over 2, my cosine is going to be radical 2 over 2. For my 60-degree angle, my sine is going to be radical 3 over 2, and my cosine is going to be 1/2. So here's my sine, and here's my cosine. So something that I want you to notice on all of these, I keep writing theta, and we're talking about specific degrees, 60 degrees. What I want you to notice on all of these is that my x value ends up being cosine, because you're always going to have that adjacent is going to be the x value over the hypotenuse of 1. And my sine is always going to end up being the y value, because I have that opposite is the y over my hypotenuse of 1. So what we have just found by finding all of these ordered pairs is we found the cosine and sine of every single angle in the unit circle. So we could point to something like this 5 pi over 6, or 150 degrees, and say, I know that the cosine of 150, or 5 pi over 6, is negative radical 3 over 2, and the sine of 150 is 1/2. So every single x here is the cosine of that. Every single y is the sine of that. It's beautiful. It's a beautiful world. And you might say, okay, well, where does the tangent come into this? And the tangent comes in just the fact that tangent is always opposite over adjacent, yes, but it is also, since my sine ends up being what the opposite is in the unit circle, and my adjacent ends up being what the cosine is. My tangent is also just sine over cosine. So if I wanted to figure out tangent of 7 pi over 6, all I would have to do is know the sine and the cosine at 7 pi over 6. So if I'm looking right here, my cosine is this negative radical 3 over 2, my sine is negative 1/2, and use the fact that tangent is sine over cosine. So I'm going to have my negative 1/2 over my negative radical 3 over 2. Okay, for something like this, first of all, I'm dividing negative divided by negative, so it is going to be positive. But I want to go ahead and flip that second one and multiply. And then just like my radical 2 over 2 earlier, I want to simplify this by rationalizing the denominator. We never want radicals in the denominator, and so we're going to have our radical 3 over radical 9, which is just 3. So that's how we would find the tangent from our sine and cosine. So this might seem a little lengthy, but it is what we would be doing in class because it's important for you to see all of it visually, both in the unit circle, but also just any form that you can. Write it down, work on memorizing it, I think is helpful. So if you can print this, then go for it, a blank one for you to fill in. But if not, I would encourage you to go ahead and write this all out. I know that it's a lot, but I would go ahead and draw one for yourself so that you can fill it in. We're going to start by, since this is all in degrees at the top, we're going to start by putting in the radians at the bottom because we're working on that. So I want to encourage you to go ahead and pause the video and see if you can get the radians for 0 to 90 degrees. See if you know what the equivalent for those are without looking anything up. Go. If you had trouble with that, that is something that you need to start working on. If not all the way from 0 to 2 pi, at least that first quadrant. That's going to help you out a lot just to know what each of those are. Okay, so we're going to go ahead and jump into sine, cosine, and tangent. Remember that you are comparing all of these to your unit circle, that your x's are all cosine of that angle, that your y's are all the sine of that angle. But you can go ahead and start filling it in from your unit circle. So once you've gotten all of your sine and cosine done, first notice some patterns that we saw in the unit circle as well. That we've got cosine being negative in the second and the third quadrant because it's talking about x's, so that's where x is negative. And then sine is negative in the third and fourth quadrants because that's where y is negative. So some things that we can see here. Also, just other things that, that we noticed in the unit circle as well, that when sine is 1/2, cosine is always radical 3 over 2 and vice versa. Just have to check the signs after that. And then they're always radical 2 over 2 together at those 45-degree reference angles. Okay, so the last thing that we're going to do today is look at tangent. And we had already done one of these, but basically for every single one of these, I have to divide my sine by cosine, which is kind of nice the way that they're written because I'm just dividing that first column or first row by the second row. So I've got 0 divided by 1 is just going to be 0. Let's look at a couple of other ones like that. My 1 divided by 0, ooh, I cannot divide by 0, so that one is going to be undefined. This marker is not great. My 0 divided by negative 1 is 0. We've got another undefined at 270 degrees, and then 0 at the end. Okay, so those are pretty easy to do in our heads. Another one that you might spot that is easy to do in our head are the ones that are 45-degree reference angles, because they're all the same aside from signs. So my radical 2 over 2 divided by radical 2 over 2 is just 1. Same thing is happening at 135, but one of them is negative, so it's going to be a negative 1. At 225, negative divided by negative is going to be 1. And then a negative divided by a positive is a negative 1 at the end. So the only ones that I'm missing are my 1/2 divided by radical 3 over 2. And my radical 3 over 2 divided by 1/2. we already did one of these. We already looked at our 1/2 divided by radical 3 over 2, and we found that it was always going to be a radical 3 over 3. We just have to check our signs on those. So any of these where sine is 1/2 and cosine is radical 3 over 2 is going to be a radical 3 over 3. So right here we've got a radical 3 over 3. At 150 we've got a radical 3 over 3, but it has a negative, so got one negative. At 210 we've got a radical 3 over 3, and it's positive. And then at 330 we've got a radical 3 over 3. So the only one that we have not worked is the radical 3 over 2 divided by 1/2. So I'm going to flip and multiply. And this one does not take any simplifying, it's just radical 3. So we're going to have radical 3 here, a negative radical 3 at 120 degrees, a positive radical 3 at 240, and a negative radical 3 at 300. Notice the areas where tangent is negative. It's going to be in quadrants where x and y are opposite signs. So that happens in the second quadrant because x is negative but y is positive, and then it also happens in the fourth quadrant where x is positive and y is negative. So opposite signs, same signs in the first and the third quadrant, both positive or both negative. So that's why our tangent ends up being positive. Watching the video back, I realized that I didn't put a negative on this radical 3 over 3. It definitely is negative. But, you know, mistakes are a part of life, right? See you guys.